Good day, this is Professor Will, CBMD PhD. Today's Wednesday, October 27, 2021. It is 3:35 and 30 seconds a.m. Eastern Standard Time. Today's research, new molecular mechanism. So let's hop to it here. The specific molecular mechanism that controls the transition from acute to chronic pain. Previously unrecognized control point, identified as target for drugs that block transition. Date October 22nd, 2021. Source, University of California, Irvine. Findings from the study titled NAAA, Regulated Lipid Signaling Governs the Transition from Acute to Chronic Pain. New science advances show that disabling an acetylthalamine acid, amidase NAAA, an intercellular enzyme in the spinal cord, during a 72-hour time window following peripheral tissue injury, holds chronic pain, development in male and female mice, delineating the nature, localization, and timing of the events involved in pain. Chronically is necessary to pinpointing control nodes in the process that can be targeted by new classes of disease, modifying medicines beyond analgesics. And this study is the first to identify that NAAA, a previously unrecognized control node, can be effectively targeted by small molecule therapeutics that inhibit this enzyme and block the transition from acute to chronic pain. Chronic pain involves from acute pain caused by the physical trauma of tissue damage due to surgery or injury, and is a massive problem affecting more than 1.5 billion people worldwide. Chronic pain continues long past tissue healing, is often resistant to therapy, and remains seriously undertreated. Treatment is largely dependent on a handful of analgesic drug classes, such as opioids, which may lose effectiveness over time. It can also lead to addiction. Nerve damage is considered to be a critical factor in the transition to chronic pain, but the underlying molecular events leading to its emergence have been poorly understood. The new research findings suggest a new class of drugs, NAAA inhibitors, can be used to treat various forms of chronic pain, and in preventing incisional and inflammatory injuries following surgery. Good day, this is Professor Will, CBMD PhD, on microbiology, bioinformatics, and pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.